thank you all for coming at the last talk of the last day. And I'm going to be talking about emails today because that's something new. And who I am. I am a security engineer at Secure Network, which is a penetration testing and security assessment firm in Italy, Milan. We do all sort of stuff, but what I do in my free time is mostly programming and being a geek. I do whatever happens to interest me, and I code stuff and I try to solve problems. So once I had to deal with emails, I got a phishing email, a likely phishing one, and I was wondering, is this authentic? Who has used emails in the last week in this room? Okay, I see it's still something mainstream. So, who likes emails? Okay, that's cool. So that's something we all hate, and that's something that we can't get rid of. And if you start digging into emails, what you discover is just it's all text. Whatever you do, you forward an email, you reply to an email, you do every kind of stuff with an email, that's just text. As HTTP is just text, email is the very same thing. Here, you can find an email that I got last week from the organizers of the conference. You see delivered to header, a return path header, a from header, and the content of the email. I've cut a lot of stuff because every time you try to send a one-word email, you're probably going to be sending about a 2 kilobytes amount of text just to say hello. So I started looking into it, and I noticed weird stuff, because if you get phishing, you should try to analyze everything, and if you have a kilobyte of headers, that's not going to be easy. So in 2018, I was wondering, how can I get through all these headers? So I wondered, how is this still a thing? I mean, it's been a long time since emails have been out there, like 40 years, and we are still wondering, is this authentic? Is this phishing? Every time you connect to a web server, every time you connect to a service that uses HTTPS, you're sure, you're positive that's authentic because your browser does that for you. But when you get an email, which may contain your passwords, which may ask you to authenticate on your banks, so every kind of tiny bit of your personal data, sooner or later will go through an email. For that, we don't have anything. I mean, we have stuff, but I'll show you that's not very good. So, phishing. The first thing that I tried to tackle down was phishing, because when we do penetration tests, one of the things we try to do is to get into the company. And to get inside the network, you can look for vulnerabilities. That's what we usually do. You can look for easy access to the internal network through exposed guest Wi-Fi networks or Ethernet ports, but the easier way is just to send an email to the whole company and just let them click on your executable and you're in. So we try to do that, and sometimes we get bounced by a mechanism that is there to prevent that. SPF is the first mechanism I'm going to talk about today, is one of the many that are broken, so that's a spoiler there. When you send an email, what happens is that you don't actually send the email. You ask your email provider service to send the email for you. So you send your email to the server then is going to contact the destination server, which is then going to check if the original server is authentic, and then only after that is going to save the email on the server. After that, you need the other endpoint of the conversation to connect to his server, fetch the emails, and that's how you connect. That's why emails are not that fast, they're not chat. So this part is crucial, and that's what I'm talking about today. The part where the receiver server tries to understand if the email is authentic. Because what they get is just a connection from an outsider IP address, an email, a valid email, I mean, syntactically valid email, and they have to understand what's going on. What happens for SPF is that the return path header is checked. How they do that is that they connect to the DNS service is set up on the server, and they ask for the TXT and SPF records. Those records have to be there, otherwise there is no checks performed, and every email is assumed to be safe. If those records are there, they are validated against the return path header. This is important because that header shouldn't be forged to avoid spam. The way it works, this is a string for a valid SPF record, and what it says is the version of SPF, which is 1. A stands for the server that resolves for that domain is allowed to send emails. So for example, if you receive an email from food.com and the IP address is the same of food.com, that email is authentic. Then there is IP4, and that's the whole subnet. That whole subnet is allowed to send emails. And that's the very same thing. They just authenticate you by your IP address. In this case, it's not a domain, it's just an IP. Then there is an include call. This is very common. Don't think this is unusual. Every email address that relies on external services or on Gmail or on Outlook, those have an include. Include is the same thing that I've shown you up until now, but performs a recursive call. So it starts resolving the SPF record for the other domain, and it goes on for at least 10 steps. Then, after 10 steps of recursive calls, the server is allowed to just give up and assume the email is authentic. So, be careful because the include call can include other include calls. So this can escalate pretty quickly, and they're executed in order. So in this case, the include statement is the last to be executed. Then there is a -all, which means if you got to this point, you can think of it as an IP table rule. If you got to this point, it means that nothing has passed, reject everything. The minus stands for reject. If you got here, just assume it's bad. This is one of the effects. This was among the bunch of text that was in the original email that I've shown you in the first slide. One of the headers said, received SPF, which is a custom header that Google added to Gmail, pass. Domain of michael@secured.ch designates that as a permitted sender, which means Gmail got an email, realized it came from an IP address, resolved the SPF record recursively 3 times, and then realized that IP address was allowed to. This incredibly huge black rectangle that you see there is me trying to do that by hand. The commands I typed are on the left, and that's not easy to do by hand if you want to check manually why an email failed a check or passed a check. Because how many of you have seen a message like, Thunderbird thinks this email might be a scam? When you see that message, what I think every time is, and how does Thunderbird knows if this is a scam email? That's not something you can guess, unless you do that by hand, which is not nice. Got to this point, and then I thought, okay, my original phishing email passed everything. It was correct up to this point. And then I stopped and I thought, yeah, but it's validating the return path header. What's that for? What's that used for? Turns out, nothing. It's completely useless. So SPF was made to avoid spam, not phishing. So it prevents people from sending email that have a return path for an address that you want to spam. So if you're an attacker, you can't forge that header. But on the client, on the email client, what the final destination point will see is not the return path header, is the from header. So the from header is what you see in your email client, which means SPF completely fails at protecting you from phishing. And this is an example of this attack. This works on any email provider. I tried it with Outlook and Gmail. It works. So you have a target. You send it to, in this case, Gmail. The return path is correct. I was sending it from my work email, so the SPF record checked and passed, so I was allowed to. Problem is, the from header was from a domain that in that case didn't even exist, but you can put any header there. And my Gmail account that was owned by me, my Gmail account didn't flinch. It was just an authentic email for him, which was bad enough. Then I realized, what if it fails? So what happens, what should happen if an SPF check fails? So I went to the RFC, something that I don't usually do, but sometimes you are left only with that. So I read through the whole SPF paper, and there is nothing about it. There is no policy. If an SPF check fails, you are left with yourself. So if you're implementing an email server, you have to decide two things. And if there is any developer in this room, they can understand why these went bad really fast. Two things. You either drop the email, so your server doesn't work in many cases, or you keep it. What do you think happened there? Everyone was keeping every email, so SPF basically did nothing. So they decided to make a new standard, because we already had one, so why not change it? Because they created a new standard, which was DMARC. DMARC didn't invent anything new, they just upgraded SPF and DKIM, which is another method that I'm not going to explain today, but I'm going to talk about for a while now. DMARC, what it does basically is just checking the SPF record in a more thorough way, and the DKIM record in a more precise way. DKIM is a signature. This provides a cryptographic algorithm to validate and sign your emails, which works pretty good if you don't want your email to get anywhere. Because if you forward an email, if you relay an email, if you have an antivirus checking your email, or whatever, if there is someone breathing on the email server while you send your email, that's probably going to fail. So this gives a ton of false negatives, and that's why it's almost never used. And even when it is used, it fails so many times that in the DMARC record that I'm going to explain in a second, it's just written, okay, if that fails, just keep going and just report it to me, because I have no idea why that's failing. So this is hard to implement, and there's a paper that I linked in the slide on why. And SPF, we've already seen that. So how is that upgraded? The from address is checked. So yay, they got that. And also DMARC allows the developers and the sysadmins to tell what to do if an SPF record is failing. So if you're just doing an email campaign, you don't care if your SPF record fails, because you're not going to carry any important information. So you want just, for example, to set up your DMARC record to say, okay, if it fails, just keep going. Might be an acceptable solution. Just report it to me so I can detect if someone is phishing my name. In another case, if there is private information going through email, you might want your DMARC record to say, delete the email, warn me, and warn the postmaster so they can take action. For example, when you receive an email saying, there is someone phishing in our name, please don't click on the link in those emails, that's probably how they were warned about it. Because some DMARC's record failed, so they got warned, and so they can react. Or their data is being leaked everywhere, so that's another way to detect it. This is a DMARC record, and it's fairly easier than SPF if you want to stay easy and keep it fine, but if you want to make some complex stuff, it can get really, really complex. This is a fairly simple example that says the version of DMARC, this is mandatory, reject if any of the checks failed, and send an email to this account when a fail happens. This is one of the reasons why DKIM is not used, because otherwise the postmaster, the poor postmaster, is going to get a ton of emails saying DKIM has failed for no reason. So this is almost only used when SPF is present. This is very important because DMARC allows you to have visibility on what's going wrong. So if you're setting up an email, you want your DMARC record to be there. And without the DMARC record, not only SPF is ineffective, as I've shown you before, but without DMARC, you can't know what's going on. And if you've seen the talk on Sec DevOps earlier in this conference, you probably remember how important it is to detect intrusion as soon as possible. This is the result of everything together. This is the original email, says DKIM pass, SPF pass, DMARC pass. This wasn't there, so DKIM passed because I just worked. SPF passed and it was correct as I've shown you before, and DMARC passed. So, we're okay. We're good, and up to this point, no one can break anything in our email, right? Wrong. And at this point, I started thinking, okay, I got the phishing email, I detected that was a phishing, that was good. Except it wasn't, because SPF was invented in 2003, where cloud wasn't even Googled as a word, except for Google images of clouds. So it was proposed in 2003, and I made the 0 is in bold. And it became an RFC in 2014 after quite a while. So what happens when people started moving to the cloud? So they took their old email servers and they moved it to a cloud appliance because they didn't want to maintain the hardware anymore. What happened is that most cloud providers share the same IP address, the same external IP address, which means that you're left with not much of a choice. You have to add that email, that IP address as a valid IP address for your mails, which means that anyone else in your subnet can send email in your name, even if they just bought an appliance for the same cloud provider. If you're thinking, how do I solve that? I have a solution, but later in the slides, otherwise you're going to stop listening to me. So, what I did was trying to resolve some SPF records for my email in my company, which is based on Office 365. After digging for a while, I got an astonishing number of valid IP addresses to send emails from Outlook, because they have a lot of replication, one for each country. For Europe, is just Europe is 40 subnets that can send email, because they don't want their email services to go down, of course. So they have to add every external IP address as a valid one, which means it is almost impossible to keep track of all their Exchange servers around the world. Moreover, it all relies on IPv4, because they want their email to get to the target. They can't use IPv6 because no one uses it. So they need to reuse addresses. From Azure to Outlook to a lot of services in Microsoft have to reuse IP addresses, as Google does, as anyone else does. So, of those incredible number of IP addresses, I found out that 30 of them were in the Azure external IP addresses range. So I was able to get an appliance in Azure in the European server, in the US zone, and I was able to send valid emails with a valid SPF record in the name of any company using Outlook online, which means they screwed up pretty bad. That luckily the Microsoft Security Response Center team reacted pretty fast, and in 12 days they were able to move those IP addresses away from Azure and get back the control of their emails. So this is the scheme of the attack. I got a subscription, or anyone else can get a subscription for the same cloud provider of the target, which is not usually that hard because you only have to pay for that. And then there is the victim service that is relying on that IP address to be trusted, and the victim client can't possibly know if the email is authentic. That's bad enough if you don't consider that that's me in a hacker suit. I was sending email in the name of anyone else in the world that was using Outlook, also my company, which is pretty bad since we do security. So after that, they kind of fixed it. They moved away the shared IP address, and our clients, to which we reported that their problem started using a signed IP address. They asked their cloud providers to use their IP only for them, and if they didn't, they changed the cloud provider. So this was a big issue for some of our clients, which had to rely on emails, because emails are important since everyone here uses them. So some of them even left the cloud. And then at this point, some might ask, okay, but I already don't use the cloud, I don't like it, it's just someone else's computer. Yeah, but if you use email campaigns, for example, MailChimp, SparkPost, and a lot of other services like that, do you really think they don't use the cloud? Because if that's the case, then you're wrong. So I was able to replicate the very same attack that I described before, but with a slight change. So those were not on the cloud. The victim service was on their IP address, maybe their home address. The server was under their desk. But they included in their SPF record MailChimp, I think it was, which uses AWS. So I got an AWS subscription. I retried a couple of times until I got the same external IP address of one of the IP addresses that the mail campaign service could get at random. How many of you have tried to configure something to run on the cloud on AWS, CGP, or Azure? Okay, not many, but someone. Unless you explicitly ask for an external IP address, you're given one at random. And if you get that, then you have basically two choices. Using a NAT, so you share that IP address with someone else, or pay a lot more. And you don't want your manager to ask you, why are we paying 5 times more for the same service? And that's why people usually share external IP address. And that's what happens for mail campaigns. So, mail campaigns used those 3 services mainly. Also, I saw one on Rackspace, but that was a corner case because Rackspace usually assign you an IP address. And so they included anyone in their NAT, and in some cases even in their whole region. So since they didn't want to check if every time they rebooted they changed the external IP address, they included the whole range of the cloud provider, which makes sense because if you're on a mail campaign service, you want your email to get there. That's what you do. Your business is sending emails. You don't want them to fail a check. So I tried to find some solutions. One is, of course, don't use anything that shares IP address, which is easy in 2018. I mean, not that easy, but you can make everything from scratch. Or use different domains. So you can have one domain for your company, one subdomain that is only used for ads, and that can include whatever SPF record you want. And an important one that is just your domain, which doesn't include anything except your IP, the one you can trust, and that only one. I got to this whole point and I kept digging, and then I finally stopped here. And I thought, okay, with the technological means we have now, that's the only potential solution for a sysadmin. Because I was trying to suggest to my clients how to fix the problem. But then I stopped for a second and I realized, okay, but how do I check if the original email I received was actually phishing? how can I, as a user, how can any of you check if an email they got is authentic? And, you know, after 40 years of emails, you would expect something better because HTTP has been out there for a shorter amount of time. DNS has been out there for a short amount of time, and we have ways to authenticate those things. ARP, we don't, but it's okay, I think. So, you can always authenticate your mail server when you're sending an email, which you don't really care that much in many cases because you're just sending, and most of the time it's just spam. I'm not saying you do spam your colleagues, but I do. So, after 40 years of email, I was expecting a solution, but I didn't find one. I wasn't able to find any valid solution. The original slide, when I showed you those bunch of commands that I gave to validate an email by hand, is the best way that I've currently found, except for you know, actually reading the source of the email and trying to understand what's going on, thinking if anyone in the world had means to know that much about me, because spear phishing can be really precise. So if you take away all the social skills that one might have, and you want to tell users, okay, you should do this to check if an email is authentic, there isn't much they can do. One of the things that they can do is read the sources of the email. Of course, if there is an HTML link that points to something that is not what is shown in the link, that's easy to detect. But then the source IP address. As I said earlier, email campaign providers, they use the cloud. But let's stop for a second. You get a new email that really looks like phishing, but it has passed the SPF checks. So you want to know, okay, how likely it is that this is phishing? So you read the source IP address and you look at SPF record. If that is the original IP address, the one they added, so if you remember in the original SPF record, there was one IP address, or the exact IP address of the domain, in that case you're pretty safe because that's hard to spoof. But if the personal email you just got that tells you that you have won a lot of money and you absolutely have to click on the link to get it, if you want to check if that is original, and you see it comes not from the original IP address, but from an IP address that comes from a Spark post range of IPs, that is suspicious. Because you just got a personal email from a personal email address in the range of a mailing campaign service. That's one thing you can do. And one of the only ones you can do. But if they don't use mail campaigning system and you just see an IP address, there is one big surprise. In the next slide, get ready, because I didn't ever thought in my life I would title a slide like that, but use Bing. Bing, I'm sorry, I'm just putting a lot of crap on Microsoft today, but Bing is not that good of a search engine unless you want to see what services are hosted on a particular IP address. The IP keyword only works on Bing, doesn't work on Google or DuckDuckGo. So that's pretty nice if you want to see if someone is sharing their IP address with anyone else. Because if they have their website on the same address of their mail server, you can Bing it up and see if it's shared among other people. So you Bing, you put the IP address there, and you see, for example, 6 different homepages for 6 different firms or services. That is a pretty nice giveaway that they're sharing their IP address. Moreover, that's one good way to know if someone has been breached, because usually, if that's the case, and many people share that much their external IP address, if someone has been owned by a hacker, they can usually do a lateral movement and own the other service too. So, that's it. That's the whole drill down of everything that I've dug on SPF and DMARC. And before I end this up, I would like to tell you one more thing. I never ever liked emails. I would like to find a solution, to code a solution, maybe a plugin for anything, for Dovecut or any open source mail server or Exchange even. And I have a lot of ideas that we could implement or we could propose as a standard to solve this issue. Because in my opinion, there is no good solution yet. I mean, how is this a good solution? How is this a good solution? I would really like us as a community to try and find a way to protect, not us, because we are usually good. I mean, we are technical people, and if we are not, we are probably here because we know what security is. We are not protecting just ourselves. I mean, it's pretty easy for us to detect phishing just by reading through a text. But what if we want to protect our parents or our nephews, our small nephews, or anyone else in our services that we would like to get the authentic stuff and not the bad stuff? We should really think about it, because emails are there. We are stuck with them. We don't like them. There's not much we can do about it. We are stuck with them, and we should try to fix what we have. And that's it. That's on us. I mean, on the security community, if we haven't found a solution for this yet. I mean, we have 27 different implementation of SMTP on the server side, but we have no ways to check it. We should, at least if you have the means to try and find a better solution, this would be a good time. I mean, it's only been 40 years. Thank you.
So I don't know if there's some questions.
Any question is fine. I mean, don't be afraid.
So you can sign email digitally? What's your view on that in this regard?
You could sign email digitally, and that's part of what the DKIM does. Problem is, for example, the key that is out there to sign, your public key, needs to be distributed somehow. So the way it's currently done is via DNS, and that's one way, because also SPF relies on that. Problem is that DNS has a cache, and sometimes a pretty long one. There are no means to revocate the keys, because there is no upper authority. There is no one above DNS. So if the key is compromised, you're relying on something that is compromised and you cannot take back. Also, if you sign an email and then that email gets relayed to from another server, or you have replication, all your servers have to share the same key, which is, how can I put it, dangerous. So yeah, that's how DKIM works, but it has been proven wrong a huge amount of times. We could use PKI, as we do for browsers currently, but we have to rebuild a public key infrastructure for email, which would probably take a while. I'm not saying that's a bad solution, it's just not ready. We are not ready for that. Does anyone has a question on anything else? Okay.
Well, thank you for the presentation.
Thank you for coming.